Hey, what's up? Jason here from Unity3D.college. If you haven't seen it yet, the 2018.3 beta is available for Unity developers now. And today I want to talk about something very specific in there that I'm pretty excited about, and that's the new C# 7 functionality. Today I'm going to cover some of these new features that are available. I'll show you how to read the new code. It is a little bit different. And some of the cool things that you can take advantage of when you upgrade to 2018.3. The first thing I want to show is the new output parameter functionality. So we've got a scene here with a simple script on an empty game object and then a text mesh pro text to demonstrate what happens. And let's hit play first and just show the functionality, and then we'll look at the code. So here you'll see if I put in any number, we get the number there. If it's blank or not a number, we see nothing. So let's open up that script. And here, this is the old way to do this. So normally, if you wanted to parse a string and turn it into an integer, you would create an integer, call int.tryparse, give it the text that you want to parse, and an output parameter, or output to this numeric value parameter that was defined up above. Now this change, while small, is a bit better, because you can see here, if we look down in the update at the new way to do this, we can actually declare the integer inside our tryparse. So we no longer have to pre-declare this. And as you can see with this example below, a much more common situation is just something with raycasts. Normally I'd end up writing raycast hit info, semicolon, and then going through and doing this. Now I can just add the type right here, and the variable will get automatically created if this is true. So if this happens, this physics raycast is true, we're going to have the value of the hit info right there, and it's created without us defining it up above. Again, this isn't a huge thing, but it is nice to know about, and it's important to understand at least how to read this when it happens. And I think going forward, it's probably the syntax that I'll use most of the time. The next feature is one that I'm not personally very excited about, but I think it's kind of interesting and really important to understand so that if you see it in code, you know what's going on and it makes sense. And that's the new local function feature. So here you'll see we have a public class that's a mono behavior called local functions, and in here we have our standard start method. But right after that, you'll notice that we have a function declared inside the start method, and then we're calling the function from inside the start method. And this works. We could do this for situations maybe where we wanted to do something a little bit bigger or recursive or something, but I haven't really found a lot of good use cases for this, like I said. But, like I said, again, it also does work, and it's something that you should know about. Just so if you see it in the wild, you know what's going on, it doesn't look like an error. Of all of the new features coming in C# 7, I think that this one I'm about to show is probably the most useful, or at least the one that will get used in the most places. And that's the tuple return values. So here we have a player with some health. See, we have a script called tuple health. And then over here under the canvas, we have a tuple health UI script. So I want to open up the UI script first and show what it's doing with the results, and then show you how to return them. So let's go into this UI script. And right here, of course, we just find the tuple health by using find object of type, since it's not on the same game object. And we're caching the text mesh pro text so that we can update it. That's not the cool part, though. The cool part is in our update. And it's this new syntax right here. So we're getting back an integer of the current health and the maximum health from this one function call. Now, in the past, what I would normally do is create a struct and then return that struct that has the info for both of those if I need to return them both. But now we can kind of bypass this using our new tuple return values. And here you'll see that we can use current right here, and we can use max right there. So how does this work? Well, let's take a look at get health. Here you'll see that we actually just define the multiple return types, and then we return them just like this, passing the first and the second. Now the name here doesn't matter so much, it's just pulling these names or using these variable names. Where we assign the name is really on the caller side. That's where this current and max are coming from. So we're assigning them here so that we have these variables on our caller. Now I can think of a lot of situations where I would use these, mainly cases where I need to return more than one thing, obviously, but usually it's when I need to return a data structure, but it's kind of a small data structure, 2 or 3 things, and it's not used somewhere else. In that case, I think that this is a great option to just return back multiple values nice and cleanly. Expression body properties have been available since C# 6. If you haven't used them, don't worry, you'll see that in just a moment too. But the new feature allows us to do expression body methods. And here we're using that to just display some frame rate info. So here it's 59 to 60 frames a second. So let's take a look and see what the code looks like. Here we have our expression body method class. And the first one that I wanted to show, this is the actual new functionality for C#7, is this getFPS method. And instead of defining out a whole method and returning something, we can use the little lambda operator here to create an expression body method. What's going to happen is when we call getFPS, whatever's after that is what's going to be returned. So it's just kind of a nice, simple, shorter way to return back some information. It's not a huge saver of space or anything, but it, again, is really important that you understand this and you see it and you don't get confused and, oh, hey, what the hell is that? This is just a new syntax for returning things back. And if you haven't seen it with properties, this is the property version. You see, it's exactly the same, just cut these guys off, and now it's a property and not a method. Let's see the code that's calling this as well. So if we look at getFPS, you see, here we're just setting a text to the getFPS value. We call it exactly the same, no real difference at all. This last feature I think is kind of the most interesting and the most exciting. It's the one that I'm certainly most excited about, and this is the pattern matching. So here I'm just going to hit play. Let's watch what happens, and then let's look at the code. So we've got a cube and a sphere dropping. You see the sphere gets smaller, the cube gets bigger and bigger and bigger, and tips over and ruins the whole thing. So how's this happening? What's so special about it? Let's take a look. We have this pattern matching trigger box here. And you see it's just a box right above the ground. This is what was actually causing them to change. And here we just have a box collider with it is trigger checked. And then we have this pattern matching script. Let's open it up. So first, just take a quick look. See what it's doing and see if you can kind of understand what's going on. So we have an onTriggerEnter method, and where we get our collider for the thing that entered our trigger. And then we have a switch statement. And if you take a look at the switch statement, you may notice something. We're actually switching on this collider object. Now previously you could only switch on primitives, integers, strings, enums, something like that. You couldn't just switch on an object. Here, what we're able to do is switch on this object, and in the case of the type, we're able to do something. So here we can say, if this other is a sphere collider, then we're going to divide the scale by 1.5. If it's a box collider, we multiply the scale by 1.5. But that's not all we can do. We can also add extra conditions here. So here we could also say, if it's a box collider, when b.transform.x, is less than 5. So here we would only grow it when the local scale is less than 5. In fact, we could even copy this and paste, and then say, hey, when it's greater than or equal to 5, we're going to shrink it back down. So now it will grow up until it gets to 5 and then shrink back down. Actually, let's see it in action. Now I can think of a lot of really cool use cases for this and a lot of places where this just will simplify and shorten the code so that it's just not so verbose. And is my box not shrinking? Oh, there we go. Perfect. So it's getting smaller and then it's getting bigger because it's going in and out of the trigger area. But I think you see how it all works. And look at that, the little sphere is shrinking. But anyway, I think this is a really cool feature. There are a lot of uses for this. A lot of cases where you just run into kind of complex patterns that you want to match on. And now it is dramatically simpler. So definitely recommend trying out pattern matching, if nothing else, from this video. So those were just a few of the new features coming in 2018.3. There are quite a few more, and I plan to cover them in the future. So if you're interested in learning more about what's coming up next, don't forget to like and subscribe and share with all your friends. And thanks for watching.